Hi. The title of my talk is "Build Apps, Not Platforms: Operational Maturity in a Box," and I really had a really hard time preparing this talk. I didn't actually make the title, so I was like, yeah, people, and this is like such a salesy title, and I was very uncomfortable. So the title changed several times over the last few days. And then I put it back on because it was on the program, and I don't want to lie to you. And because I think I figured it out, and I hope I won't be boring, and you'll find it interesting. Clicker. Ooh. So a couple of assumptions coming into this talk. And the first one potentially is that we kind of, if you're in this room, there is a very high chance you consider cloud to be a good thing, right? You might be running some on-prem, but generally, like the cloud one, it's over. And if you're doing any kind of cloud, I would assume you say, like, DevOps, good. Whatever we were doing in the 90s doesn't really match, and we actually have to have some level of automation and tooling. And so the specific talk today is about a subsection of whatever DevOps cloud things we do, which is called platform engineering. And the question would be, platform engineering good? Click. Like any serious speaker, before doing the talk, I Googled like the subject of my talk to see what Google says, and very helpfully you end on the Gartner, and they explain therefore that platform engineering emerged in response to the increasing complexity of modern software architectures. Today, non-expert end users are often asked to operate an assembly of complicated arcane services. This is Mr. Paul Delorey. I have an issue with like there's no distance in which I can see anything. And it's basically kind of the idea that the industry has figured out that banging together a couple of dozens of different services at the end of the day might lead to certain complexities. There's an impedance mismatch. I really like the impedance mismatch moniker, like the idea that when you connect a circuit with 12 volts to something that is running on 5 volts, you're going to end up with a problem. When you're assembling your DevOps cloud structure, there might be different levels of SLAs between different services, but even more so, like slightly different APIs, slightly different ideas about security, slightly different ideas about how you identify a user. So this is basically like the cycle, the good old cycle of IT, always the same. It's like low code, right? Low code is cool now. Microsoft Access is from the, and this is this IT, the cycle where we're in a phase of what they call urbanization, right? We have all of these slums growing everywhere, and we say, okay, this was really fun. All of this was very productive, but now we need to put some order into it. We want to build a platform, some kind of contract with the organization about how we develop software and how we deploy it and how we operate it. I have a clicker. And when you're going to do that, you're kind of, and you don't want to be, doing it for the first time and you're a baby and nothing works. You want to do that seriously, like professionals, with what we call operational maturity. So I'm going to try to give my own definition of operational maturity. And the first thing is potentially a bit weird because it's kind of a doubly negative. And it's like a strict definition of what non-failure looks like. It's really difficult to define a system working well, right, in a way, because everything fails all the time. It's not because everybody's doing a great job that nobody's going to get a 404, right? A 404, it's one of these errors when we say, hey, it's you're looking for something that is not there. Although, often enough, the 404 is our fault, right? We deleted something, we moved something, we didn't redirect. Every system that is going to be running at scale is going to be running in some level of failure mode. And we want a definition of what non-failing, what okay looks like. And then you have, therefore, these kind of failure scenarios that are known. You know, the failure scenarios you test against. You can define them. You have the non-failing system, and then you have a failing system, and you can now define it. And if you can define it, if you can say, this is the system not working, I can, therefore, build tests for it. And these tests, you know, are going to define my failure modes and potentially the indicators of how I handle failure, right? And I want to know, when I'm going into failure mode, how much time, money, effort is it going to take me to go back to a running state? And potentially, what would be this state I'm getting back to, right? What is the non-failing mode? And also, and here, you know, in the industry, we talk about RPOs and RTOs, kind of important in how, you know, how soon can I be in production again, and how old are the backups I'm restoring from. And when you achieve operational maturity, it's basically this capability of handling failures in a very high frequency. Right, and this means basically that when we're talking about these like small degraded stuff, this cycle of handling failures often basically means that you're potentially getting rid of those, right? All of the red things, you get a bit less often of those because you're handling the failures often. Potentially you have automation in place that is capable of handling it. Work? This is a failure, right? It doesn't work in the SLAs. And in a way, you're on a voyage, right, to achieve this operational maturity. And I posit here that how do you do that? You basically, one, have multi-layered observability. And multi-layered observability is really, really important because you have a hierarchy of observability. It's, if you're going to look at a system that is composed of tens of thousands of services running, a service not running is not the system failing, right? It's normal operational 10,000 services not running is probably much more of an issue here. And these are, you know, and this multi-layered observability is about both positive signals, saying system, heartbeat, saying I'm okay and I'm functioning to specs, and these other service level indicators, these SLIs, that go down and say, hey, probably I have some level of degradation in my service. And within those, you have, and you know, when you can define these observability methods, it means also, and you have a strict definition of non-failure, there is probably a way for you to start writing interesting code that will allow you to go automatically back to non-failing mode. But as a matter of fact, we know that life is hard and everything is broken, and that all of these known failure modes will have friends that are just stuff breaking. And everything breaks, right? And however people are incredibly charming in their blog posts and look like, this is so incredible, like Cloudflare. It's, you know, technology from the future. They have better engineering than they don't. And they fail, like, and they go down for days, these guys, from time to time. So, and you know, and as we're working in an ecosystem, we all agreed the cloud was a good thing. It means that very probably you are going to be suffering from some of their failure modes. And then you actually have to have the people that are trained to handle those and have the processes that allow to do that quickly enough. And again, and you can't really train for that in a way, right? You don't, these are the unknown failure modes. And potentially you go through fire drills often enough up until the moment in which you actually can handle new kinds of failures efficiently. Okay, I didn't present myself, I am. So, Berg. Okay. Hi, I'm Ori Pekelman. I'm one of the founders of Platform.sh. And, okay, I'm going to use the keyboard. And I'm now, I have like a cool title. I'm Chief Strategy Officer. because I really like cool titles, and Fabien was much better for the job of product than I was. Now, one of the things is that I'm also a developer. So this is evidently generated by Stable Diffusion. And I've written code in, okay, I'm not going to read my notes. Let's see if I can remember. Like, I think Z80 assembly, GW Basic, Clipper, it's a language, actually. Delphi, Turbo Pascal, PHP, and like, I have written and you can, go on my GitHub and, oh, yes, really. Oh, yeah, I have a GitHub. Yeah, and actually, I did if memory serves, a Symfony 1.2 project. So this is like, I don't know, but 2008, I think. And so I have a very old profile on Symfony Connect, which says that I'm a VP of marketing. So I actually, like startups are a really crazy thing. So I actually ran marketing for Platform.sh for a while. And this is what the Symfony, officially, I think even on the title of the presentation, it was said Symfony. And and when you're a startup, and at that time we were like 20 people, you gotta do more with less. And and from all of these stories of all, like when my kids have to explain what daddy does for a living, always very, very complicated. Like Mark said. So anyway, when you go and you're a developer, and someone like that guy tells you now you do marketing, you say, okay, this is a domain that can be automated, right? We have the tools, and I'm like not a lot of people myself, and I know how to code. So these are like cute Apex, cuteness competition of Apex predators, and I can write code in Apex. Apex is the language. So how many of you know Apex? Wow. You're such happy people. You have good bosses. This looks like Apex code. All code looks a bit like the same. So this is the language you write Salesforce in, right? It's the language of Salesforce. And I was like, okay, Salesforce is a PaaS, it's a platform as a service. You can write code. This is going to be easy. I'm just going to put it under Git control, write some tests, absorb some technical debt, and go from there. The word just, right? Hey, just. So yeah, you can, and you kind of really quickly figure out that just doesn't actually work very well in life. And I almost got everything under Git control. It's basically impossible, and I was like really happy about myself because there's, and you can even create, like with Platform.sh, you can create these ephemeral staging clusters. So you can just, create a copy of your whole Salesforce, so you can not write code in production. But then again, you discover that it takes a day or two and might fail. So you come back the other day, and you want to run your tests, and it's like, oh, no, let's start it. And I was actually supposed to be running marketing, and this, events and swag and figuring out taglines. So later, there was some poor Salesforce consultant that came in and removed everything I did, and did Salesforce like God intended it with clickety click click click. And now we have actual professionals that take care of it. I mean, and I personally discovered the idea of the existence of sales ops quite recently. So I took away from this thing two things. One, just code, and something ops is actually a job description. So there are people that are, so this is a segue. We're going to go back to the actual talk, but it's gonna buckle back. So 6 years ago, I did basically the same talk, here, not here. It was like the other side, and almost Paris. And the title was How to Build Cloud Native Applications. and it was in French. But it was basically the same subject, right? It's basically, in a way, how do you get from this lamp to be using these capabilities we already agreed that cloud was good, to be using these incredible capabilities that a cloud platform can give you. Like, you know, just-in-time provisioning, don't have to buy a server and have it delivered, horizontal scalability, the multiple locations to which you can deploy. And basically move to something like this. And I think all of you were in Fabian's talk earlier today, and kind of, you know, and we haven't, you know, it wasn't discussed, but as a matter of fact, in order to do all of these evented, right, kind of things, you actually want to have a message queue in the mix somewhere, right? In a normal application today, so if like a normal application 10 years ago, or 15 years ago, a LAMP stack would do just fine, it would be difficult for it to use these capabilities coming from the cloud. And there are actual things that it won't do well, like everything evented. And when you look at 2016 and my talk from before, basically all of these services that you look here, you see here mostly, like the nice normal kind of scalable architecture without any bells and whistles, right? There's no like machine learning-y thingy there, it's just a PHP application. Most of these came as primitives from the cloud provider, right? We started to have, beyond S3 and EC2, beyond the machine and the network, we started to have some other things. And, but in the end of the day, it's like, I'm gonna use, it's all simple and just, hey, it's just running programs on computers. And I want another segue. And computers are a very, very simple thing. A computer is just, you know, CPU and memory, disk, networking. That's the baseline. We have processes running on them. And kind of important, we have names, like distant names for these processes. We have a way to resolve from, this is the web, right? We've finished the web here, we have DNS, it goes to network, there's a process answering, reads from the disk, does something in CPU. And the processes are the important thing. This is what you guys do, you know, in life. What you do is write the code such as that there will be processes, but as a matter of fact, they don't run on computers, not directly. The only thing that runs on a Linux machine is an ELF binary. At any rate, even if you're running PHP, the processes themselves is something that is source code that will be compiled. Computers do not run in real mode. And so kind of the non-simple part of, so that was really simple, but the non-simple part is that when we're saying we're gonna be running these programs, they are going to be written by not a single human, but multiple humans that will need to collaborate together on that. And they're going to be using a lot of third-party libraries, such as Symfony, right? Or the Linux kernel. We're not all running, you know, writing our kernels by day, you know, by hand every day. And we're interested in the quality in which they run. And this quality is defined by also this rhythm of change of the program, right? We want to be able to make these programs evolve. The market changes around us. The supporting libraries we're using, even when they don't change, they change. Because now we know that they have security vulnerability in them, and we have to change them because their quality changed, right? They were the non-vulnerable library that we were using yesterday, and today the same one is the vulnerable library. And at the end of the day, money happens in our world when there are a lot of users on the other side that are going to be using our program. And this is like where the whole, we'll go back to it later. So, and this is why I told the marketing story. Yay! There's a simple solution to that. Let's just write some code. And this is what we call infrastructure as code. Like my Apex code has a business domain, very simple, leads and opportunities. The infrastructure, one slide ahead, I'm so sorry. So yeah, but you understood the idea. Hey, just code, let's code the infrastructure, put it under the Git control, write some tests, and everything will be fine. And and the business domain of what we're going to do this precisely the same way, and as easy as it was for me to get Salesforce under Git control, we'll just get everything under Git. And I let this other code manage the relationship of my code that will generate those programs and its relationship with the underlying infrastructure. So, and again, and when you say, the business domain of my Apex code, leads and opportunities and sales and stuff like that, here the domain is whatever cloud native means. Whatever are these underlying things that I'm going to be orchestrating. And, and it started with a disk and a machine and a network, and very early on SQS, like messaging, good for. And then, value-added services upon value-added services, many of which do basically the same thing. Today, there are 289 different products just from, it went too fast, just from AWS. So this is before you consider that there are potentially values not to have a full vendor lock-in with a single provider, right? And when I did this talk 6 years ago, I was basically arguing to the same people potentially that we can move from 4 concepts, LAMP, to around 8 concepts, right? Let's add some caching, let's add some redundancy to the mix, right? Let's move away the storage layer into a distributed, replicated storage layer somewhere else, so we can potentially move workloads between machines, and how we can basically wrap this up in a nice pattern around infrastructure cloud, around GitOps, and we kind of get CI and CD benefits for free. These days, there are a bit more, yeah, it's gonna turn, yeah. And it's like, this is even an incredible simplification, right? Because behind each one of these logos, there are potentially many, many different concepts we might need to know about. And it's even, and for someone like me that looks at the industry all the time, I don't even know, like, I don't actually know how many concepts I'm supposed to be, and what is, the box each one of those manages, unclear to me. At any rate, today doing infrastructure as code is doing some level of putting those things into a semblance of what we call the IT urbanization, right? And this is what the thing that I found really, really, when I was Googling for the talk. Like, Gartner actually says that they expect in 2026, 80% of software engineering organizations to establish a platform engineering team. And I found this number to be absolutely incredible. And the level of confidence with which Gartner talks about this. Like, that this will ultimately solve the problem of cooperation. Like, we have a solution at last. But evidently, this is coming from a high-level degree of suffering in organizations. This is kind of cute, because in 2016, when they talked about DevOps, before platform engineering, they weren't as bullish. They were saying, OK, people are going to be doing DevOps, good. They're going to fail. So it's kind of interesting. I don't usually expect Gartner to be right on things. Hey. And again, the kind of the transition we're talking about is about this transition between something simple to something potentially as simple, but potentially hiding behind it the enormous, frightening, so many logos I've showed you earlier. And when we're talking about this platform engineering, about this urbanization, about our capability to build some contract with our developers that describe how can we not be infected with all the complexity, just some of it. It's not just actually about managing these dozens, potentially, of open source components that are going to compose my application, but also all of these vendors. Today, it's kind of always a mix between whatever you're doing in open source and whatever the SaaS services that are underlying that you use. But actually, the platform is much bigger, right? In a way, the platform is what encapsulates DevOps as a culture. It's also something about how do we make a system in which we can collaborate with the people creating the code for the programs, such as they run on our infrastructure. And in a way, so like, as we say, about DevOps, DevOps is not about tools, it's about culture. But we know very well it's about tools. And platform engineering is basically solving all of the huge problems that appeared both from this culture and from the myriad of tools around it. And when we go back like to 2008-ish, the year of, I think 2008 is the year of the cloud. Somewhere before that, it wasn't really there. You had kind of EC2. And generally, DevOps happened. And DevOps happened in the sense, that I'm not going to say, in 2018, dev versus ops, right? You're programmers, they're somewhere else, sysops. There are so many shared responsibilities that have happened. There are so many layers in which we have to collaborate and we have a shared responsibility. But the thing is, at the end of the day, there is a job called developer, doing code that probably comes from some level of functional specifications, and this job didn't actually change much over the last 10, 20 years. I don't know if since ever. I don't feel something, when I write code, I don't feel any really different as I was before that, and I don't actually forcefully think about the infrastructure, right? How it's gonna run, sometimes. Their job, so I'm still doing, like even if so much shared responsibility, their job actually, became somewhat more complicated. So this is like, the roadmap to learning DevOps. And even the titles changed quite a bit, and these titles are do represent kind of different kinds of responsibilities or approaches to what my job in life is, between the good old system administrator and now the platform engineer. And in the end of the day, kind of what is this platform engineer compared to the SRE or the DevOps? They're doing the same kind of thing. At the end of the day, they're going to be describing the box, right? They're going to be describing the contract with the developers. They'll define the affordances of the system, their OKRs, how it evolves over time. And at the end of the day, their goal will be to achieve some level of operational maturity. And operational maturity is not, again, from my definition, it's not about being green. So I was really, really happy when I did it, like the screenshot, that it was all green. But it wouldn't be bad if Platform.sh had reds and oranges in there. It's gonna happen. We will fail. We fail. Everybody fails. Everything breaks all the time. The question, basically, of operational maturity is when you fail, how do you handle it, right? And I have here a really nice thing from last week, and it's one of our fire drills. Fire drill meaning here a whole cloud region goes on flames, unrecoverable. That actually happens, and we need to restore it into working order somewhere else. And the interesting thing here is that at the end of the day, the interesting or the important things that make it actually work is not all of the automated, there's a lot of automation that allows us to recreate a new cloud region, and this was, I think, 54 minutes to incident closed. and which meant services, it's a full cloud region, born again from backups and around an hour or so of RTO, so like data fresh. But the really interesting things are that the fact that there's somewhere in there that is saying, I am incident commander. A bit like in Game of Thrones, night gathers, my watch begins, something like that. I'm not going to do that. I just love this XKCD, but I'm going to. So, yeah, we're getting into the talk now. So, again, the domain in which we are talking, the business domain we're talking about, is managing this cycle, right? It's this standard development workflow where there's the circle of security inside because everything is security and everybody is a security engineer. And we are going to be doing the infrastructure as code. Therefore, doing the code that basically wraps all of these activities from the moment you write your tests and your code to the moment in which it gets packaged, deployed. We said that everything has to be built. And just code, right? And in a way you can think about it is that the Ouroboros. You now not only have to write the code, but the code that orchestrates the code. And one of the questions is going to be, are you going to be writing tests for this one? Do you have a testing framework for your Terraform, for your Ansible, for your Puppet? Are they even testable? Because unit test behavior, can we unit test it? Do we understand even what that would mean? So at the end of the day, this is, when you're going infrastructure as code, you're basically coding. And we tend not to take seriously infrastructure as code, right? We don't actually look at the semantics. When you are going into a PHP class, your eye will bleed on some patterns, right? You will see them and you say, oh, this is magic variable, magic constants, no, bad. Your eye is not trained to look at the semantics here, to understand what is the contract that actually the platform is going to expose to you. And, when you look at, this is our infrastructure as code, and it's not just about the verbosity, it's basically about what are the contracts that are presented by the system in front of me. And is what I'm, the lines in there, what are the guarantees that they represent? Do they give me any guarantees of reproducibility? When I have this code, and it's, hey, we just got it under Git, and we change it to this thing. I'm going to do this again, a couple of times. Very two minor things happening there. What are the system semantics? What do I expect the behavior of the system to be? Do I expect it to error out? Do I expect it to upgrade things? Do I expect the upgrade process to upgrade the data with it? Maybe, if I have 9.6 and 13, is there a migration path, and what would be the failure scenarios in which it runs? So I'm late, so just quickly about us, what we try to do is basically be that platform, right? So we call it that platform, ridiculous, and establish some kind of contract between code and potential infrastructure upon which it's going to run. And what we try to do is build it with a number of constraints that I think are interesting. So, and potentially one of the main constraints we built into it was this idea that we're gonna just be running programs on computers. And therefore, whatever I'm doing as building as a platform, and if you are not convinced in using us, I would suggest very much, at least to try to be inspired by that, to consider that you basically need two control planes. One control plane that is only interested by the semantics of the program, that describes what its dependencies are. I need a MySQL. I need, at a minimum, PHP 8, and at maximum 8.2 or 8.1 because 8.2 is not out. In a way, kind of your platform is something that sits in the middle but separates those totally, such as that you don't build this form of locking and perspective rot inside your platform that is going to link you directly to whatever one of the 100 tools we have seen there is doing currently. When you look at Terraform, you kind of always want to have one step back, such as that your code in your Git repository that is that of your program doesn't say anything about Azure, doesn't say anything about AWS. This is basically what we try to do, and what we try to do is to, kind of get and wrap everything in a beautiful, beautiful story, and potentially enable that, for the thing we've seen from 2008, probably, or 16, to some degree of not arbitrarily complex, but non-trivial application. And this is, I think, the thing that interests me with the Gartner piece there about the 80%, that we had a feeling in the last few years that platforms were a thing of the past because of Heroku, I think, right? Because they could only basically handle the use case above. We posit that it is potentially possible not only to have platforms, but to have platforms as a service and enable use cases that are just a tiny bit more interesting. This is evidently a joke, okay? But it's like a simplify Kubernetes, simplify platform, the number of results. More people talk about Kubernetes than they talk about Platform.sh, that's the root cause. But I thank you very much, and I'm over time.